Hello everyone. Nowadays mobile users are more, especially Android mobile users are large numbers. The main drawback in Android mobiles is battery backup. Due to many number of apps, the battery gets drained quickly. So to overcome the drawback, we have done our project. And now let's see in detail about our project with demonstration.
We are going to demonstrate our project. Our project title is Automatic Mobile Charging Using Solar Panel. The main objective of this project is mobile phones can be charged automatically without any typical chargers, and solar panel is used for charging purpose in this project. For emergency cases, due to low battery, it will be very useful, especially when traveling. There is no need for any external cable for this charger.
In this project, an automatic charging of mobile phone using solar energy is developed. The solar panel is fixed at the back of the mobile phone, and the main aim is to charge the smartphone in an indoor environment when the phone battery drains to 40%, and the amount of power produced by the photovoltaic cell depends upon the brightness of the radiation, and the solar charging is visible through the direct visible light. As soon as the battery drains to a predetermined value, that is the 40%, automatically the solar charging system operates. The solar charging suspends during the call, video conference and any other processes, and we use polycrystalline silica solar panel.
Now look at the existing system.
In the existing system, the mobile phone is connected to the solar charger using an external cable, and the solar charger is fixed at the window side.
And this is our proposed model.
Here the solar panel is fixed at the back of the mobile phone, and the SMD device is fixed below the solar panel. And the main advantage of our project is we don't need any external cable.
Now have a look at our block diagram. And this is the solar panel. We are going to take 5 volt supply from the solar panel, and this 5 volt will be supplied to the regulator, and the regulator is used to regulate the voltage. If the voltage of the panel is greater than 5 voltage, this regulator will be using to supply the standard 5 voltage to the controller, because controller has only 5 voltage. And the work of the controller is it is going to sense the battery level using voltage sensor. Once if the battery level reaches 75%, and the message will be sent to the controller through the analog to digital signal using a voltage sensor. And once if the signal is sent that the battery level is 75%, and now the control regulator will be acting as a switch, and this control regulator will be open, and now the supply flows through the solar panel, control regulator and through the phone. And now as the same case, once if the battery level reaches 100%, or if any ongoing calls or video calls are there, the information will be sent to the controller through the sensor, and now the control regulator will be closed, and now there will be no supply flowing through the solar regulator, and the total supply will be cut off. And since it is a prototype model, just we are using a normal components, and this control regulator and controller and regulator will be we are going to use those in the SMD device. And in the prototype model, instead of a control regulator, we are using relay. This is how our final product looks like, and this is the mini solar panel, which is 4 watt. It can generate 5 volt as the output, and this is going to be the SMD device which is going to be placed, and from this SMD device we are going to connect the mobile battery to the internal wiring. And this is the solar panel, and from here the 5 volt supply or 5.5 volt is applied to the regulator. We are using a regulator. Suppose if the voltage is greater than 5, it is used to regulate the voltage to the 5 volt, and this is the input to the regulator, and from here the output will be output of the regulator will be 5 volt. You suppose if the solar panel's output is greater than 5, it may be 5, for example if it is 5.5, the output will be 5. For that purpose we are using the regulator, and this 5 volt will be supplied to the battery. From here we will be here the positive and negative pins are there. The output of the regulator will be given to this pin, and from here we are giving the supply to the battery. and here we are using the voltage sensor. This is the positive pin. This is the positive pin of the voltage sensor, and this is the negative pin. And this both will be connected with the mobile charger. Since it is a prototype model, we are using the universal charger instead of a mobile. And the working of the voltage sensor is to monitor the voltage of the battery. The voltage of the battery is displayed here, and now the voltage of the battery is 3.6 and it's 97%. And since it is a video demonstration, we have fixed the threshold voltage as the 97%. Once if it reaches 97%, the battery starts charging, and now it is in the charging state. And we are using the PIC controller, and this PIC controller it is used to do the total process, and this is the voltage sensor, and the voltage sensor signal will be sent to the PIC controller, which is the ADC pin. Will be giving the ADC pin, and this ADC pin will be interconnected to this PIC controller, and it will be monitoring the voltage. And once the voltage reaches 97%, it starts charging. And as the same, once it reaches 100%, the charging process will be disconnected through the relay. And this is the main part of this. This is the main part. This is the relay. This relay controls the turning on and off the supply when it reaches. For example, now we have given us the 97%. Once it reaches 97%, the relay will be turned on. It will be acting as a switch. The switch will be on, and the supply will be flowing through the battery, and the battery gets charging. And at the same time, once if the battery level reaches 100, and here the relay will be closed, and here there will be no supply flowing through the battery. Now let's see the output of the solar panel, and the output of the solar panel is 5.6, and we are going to regulate it to the 5.5, and the output pin of the regulator will be third pin, and second pin will be the ground. Now let's see the output of the regulator voltage, and the output is it's 4.22, which is less than or equal to 5 volt. And this 5 volt will be given to the charger for charging purpose, and the charger's input may vary from 3.7 to 5 volt will be given to the charger's input. And now the battery is fully charged, and now the condition is charged. Now the relay is triggered.
We are thankful to our management and our professor Mr. K. Karthikeyan sir for guiding this project, and also we are thankful to the Texas Instrument for giving the great opportunity. Thank you.